Hey everybody, how you doing? Purpose of this video is to give you an answer key for numbers 1 and 4 from Applications Worksheet, but then also to explain the problems. But first, let's reveal the answers so you know if you did the problems right or wrong. For number 1, part A, the maximum height was 144 feet and it took 2 seconds to achieve that height. Part B, it's going to take 5 seconds for the object to reach the ground. Part C, it's going to reach this height of 108 feet twice at both 1/2 second and then 7/2 seconds. Part D, it's going to reach a height of 128 feet after 1 second and 3 seconds. And then part Elliot, the object will be 80 feet high after 4 seconds. And then number 4, how many seconds does his book beat yours to the water? I got an answer of 1.162 seconds. So if you got all these answers completely right, you're done, and you should hit stop and move on with your life. If you got any of these answers wrong and you're not really sure why, continue on and let's find out what's going on. Starting with number 1, friendly reminder, this is what number 1 says. Give it a second, pause and read if you'd like. But to get this problem started, you really need to start with an equation. We're throwing this object upward at 64 feet per second. So because I'm saying feet, I know that the equation needs to be of the variety negative 16 t squared, and you're throwing it upward, so it's plus 64 feet per second, so 64t, from a platform of 80 feet, so plus 80. Now if you think about a negative t squared parabola, that graph, a downward parabola has this look, and you're throwing this object upward, so the graph probably starts here and goes upward, hits its maximum, and then heads down and eventually hits the ground. Okay, part A, when will the object reach the maximum height? That is at the vertex. And when I have an ABC type standard form problem, I use negative b over 2a. So negative b over 2a, so in this case it's negative 64 over 2 times negative 16. 2 times negative 16 is negative 32. Negative 64 divided by negative 32 is positive 2. So I know that it takes 2 seconds to reach that maximum height. And then I do y of 2 to figure out what the height of this object will be after 2 seconds. So negative 16 times 2 squared plus 64 times 2 plus 80. That works out to be 4. 4 times negative 16 is negative 64. 64 times 2 is 128 plus 80. Negative 64 plus 128, that's 64. And 64 plus 80 is 144. So that's how I know, going back to the answers, that after, where did the answer key go? It's right here. That after 2 seconds it was 144 feet, because that was the vertex value, that after 2 seconds we had achieved a height of 144. Okay, moving on to part B. How long will it take the object to reach the ground? I gotta say, from talking to those physics students, I really liked that time up versus time down technique. Time up, we already know to be 2 seconds. So time up plus time down. The time up we already know is 2 seconds. The time down, you start off with this equation, and we want to know when's it going to hit the ground. So 0 equals negative 16t squared plus, at the top of this parabola, the object would just stop for a second. It wouldn't be going up, it wouldn't be going down, it would stop at that moment. So it's a 0 velocity, so 0t plus at this specific time you're 144 feet above the ground. So I have negative 16t squared plus 0t plus 144. And when you solve that out, negative 144 equals negative 16t squared. Divide both sides by 16. I don't know that one off the top of my head. 144 divided by 16. Oh, it's 9, of course. And then when you square root both sides, you get positive negative 3. But in this case, we only care about the positive 3 answer because negative 3 wouldn't make sense. So the time down was 3 seconds. 2 seconds up, 3 seconds down. That is a total of 5 seconds. Another way of solving this particular problem, instead of thinking time up plus time down, you basically want to know when this equation reaches 0. So you'd have 0 equals, where'd that math go? 0 equals negative 16t squared plus 64t plus 80. Plug this into your quadratic formula. Negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times 80, all divided by 2 times negative 16. You work it out. One answer would be positive, one answer would be negative, and that positive answer would be 3. If you prefer the quadratic formula technique, make sure you can pop all this stuff into your calculator and actually achieve that answer of 3. Oh wait, that wouldn't be 3. Sorry about that, everybody. It would be 5 because the 2 plus 3 was 5. So it would take 5 seconds to achieve that, that maximum height. So 5 seconds for maximum height. Part C. Well, part C, we want to know when the object would be 108 feet above the ground. Now, one thing I want to point out is at time 0, it was 80 feet. And it reaches a maximum height of 144. That means like 108 is probably like right there. And if you look at the graph, it's going to achieve this height exactly twice. So for this one, we should have 2 answers. So part C, we want to know when that height is going to be 108. So we take this exact same equation that we've been using and set it equal to 108. So negative 16t squared plus 64t plus 80. Now you can't use quadratic formula unless this equation is set equal to 0. So I'd subtract 108 from both sides, and it stays negative 16t squared. It stays 64t, and 80 minus 108 is negative 28. Now, I notice all 3 of these numbers are divisible by 4, and I don't like my a to be positive, so I'm going to divide everything by negative 4, and I end up getting 0 equals 4 divided by negative 4. So I get 4t squared minus 16t plus 7. And now with these smaller numbers, it might be a little bit easier to navigate with the quadratic formula. Positive 16 plus or minus the square root of 16 squared, 256. I'm 99% sure, but I'm going to put it in my calculator to double check. 256 minus 4 times 4 is 16, and 16 times 7 is 112. So I have 256 divided by 112 divided by 2 times 4, which is 8. 256 minus 112, I'm totally cheating using my calculator. That worked out to be 144. I knew that. And then square root of 144 is 12. So I have 16 plus or minus these plus or minus 12 all over 8. And then if you break this up into the 2, 16 plus 12 divided by 8, and 16 minus 12 divided by 8. 16 minus 12 is 4. 4 divided by 8, that's 1/2. And then up here I get 28 over 8. You divide out a 2, and you get, or divide out a 4, and you get 7 over 2. So 1/2 seconds and 7 over 2 seconds is how long it would take. I guess that means looking way back up here, it must have been factorable. Let's see, if it was that and that, that means that would probably 2x and 2x and a 1 and a 7. It's a minus and a plus, so they both have to be minus. Oh yeah, totally factorable. So I could have factored it, and then you gotten 1/2 and 7/2 that way too. And that's actually how I'm going to solve part D. I'm not going to use quadratic formula. I'm going to use factoring. So for part D, we want to know how long it takes to reach a height of 128. So we do the same thing, but we use 128 this time instead of 108. So I get 128 equals negative 16t squared plus 64t plus 80. If I subtract 128 from both sides, I get negative 16t squared plus 64t, and 80 minus 128 is minus 48. Now, before I work this problem, I'd think quadratic formula from the start, but then when I think about it, I notice that all three of these numbers are divisible by negative 16. So if I divide all three of these by negative 16, I get positive t squared minus 4t plus 3. And why this one looked very, very ugly, this one looks very, very easy. And I know that this is equal to t minus 1 times t minus 3. And if I set both of those equal to 0, I get t equals 1 second and t equals 3 seconds. So it achieved that height at both 1 second and 3 seconds. Okay, and that was the answer to C and D. You know, the 1/2 and 7/2 for that first problem, and then 1 second and 3 seconds for that one. Part E, part Elliott. How high is the object after 4 seconds? That's just using the equation and plugging 4 into it. So y of 4 equals negative 16 times 4 squared plus 64 times 4 plus 80. Now, while all of you are popping this in your calculator or using your brain to get an answer, let me provide a common sense approach for this one. This isn't part C, this is part E. Amateur hour. Going back to the graph. After 0 seconds it was 80 feet, and after 2 seconds it was after 144. Because it took 2 seconds to get this height, that means it would take exactly another 2 seconds to get back to that original height. So if it took 2 seconds to get to the maximum height, it would take 4 seconds to get to the original height, which would mean that after 4 seconds it would be 80 feet. And if you go back to your work here, you can work this out all you want, but this must cancel out with that, and you're left with this 80. So the answer is 80 feet. So you can use a common sense approach and get your answer that way, or you could use the math and get your answer that way. This option isn't always available to you to common sense your way, but if that option is available to you, why not use it? Okay, that was number 1, everybody. Next, I'd like to solve number 4. I need to get another piece of paper. Okay, so number 4. So you and your friend are going to be destructive, and one of you is going to drop a book from a roof, and the other one is going to throw a book on down. Not very responsible use of books, everybody. Elliot does not appreciate. Anyway, there is you, and then there's your friend Herman, and you're both throwing from the height of 160 feet. So for both people, the equation would be negative 16t squared plus something t plus 160. Y equals negative 16t squared plus something t plus 160. Now, in your case, you are dropping the book, which starts with a 0 velocity. And I want to know how long it takes to hit the ground, so it's going to be 0 equals negative 16t squared plus 0t plus 160. For Herman, the ground is still at 0 feet, but I have negative 16t squared. Now, Herman, violent fella, threw the book to the ground as hard as he could, which would mean that instead of being plus the initial velocity, it would be minus initial velocity, negative 48t, plus that height, of 160 feet. And then you solve both of these. I'm going to solve this one first because it looks harder. I notice that this, and this are all divisible by 16, and I notice that the a is negative, so I'm going to divide both sides by negative 16, which would give me 0 equals positive t squared plus 3t minus 10. And then hold on, this one's factorable. Score t plus 5, t minus 2. And when I set t plus 5 equal to 0, I get t equals negative 5. I don't think it's going to take negative 5 seconds, so I'm just going to ignore that. But if I set t minus 2 equal to 0, I'd get t equals 2 seconds. So it looks like Herman throwing the book down would take 2 seconds. Now you, on the other hand, you dropped the book, so it should take a little bit longer. And if you're to solve this one, the first step you do is subtract that 160 from both sides. So I get negative 160 equals negative 16t squared. Divide both sides by negative 16, so 10 equals t squared. When you square root both sides, you get positive negative root 10, but negative root 10 doesn't make sense, so we just go with positive root 10. And if it took your book root 10 seconds, and it took Herman's book 2 seconds, how many seconds does his book beat yours to the water? Well, that would be root 10 minus 2. So if you want to give me a nice exact answer, this, and if it says an exact answer, you would need to answer it this way for the exact answer. But who says root 10 minus 2? That nobody would say that. So you work out a decimal. Square root of 10 works out to be 3.162. And if you subtract 2 from that, you end up with 1.162 seconds. I might even just say 1.2 seconds. I wouldn't say 1 second. I'm not sure 1 second's accurate enough. But 10th, 100th, 1000th of a second. The only time I know that they measure thousandths of a second is bobsled, and soon, from what I understand, they might be doing swimming to 1000th of a second too, because those races are getting too close. They're too fast. Anyway, everybody, that's how you would solve number 4, and that's number 1 and 4 from these story problems. If you have any more questions from these 2 or 4 story problems that we've done in class today, please let me know. Have a beautiful day. Bye-bye. Elliot out.